Topic Lesson 7.2 Angles and Unit Circle. This is going to be a big one because of the unit circle. And like I said in 7.1, we are going to visit when you take the math analysis and pre-cal next years. So be aware that this is going to be a lengthy lesson for the algebra class. And should you decide to take on math analysis and pre-cal, we will revisit it again and again. Essential questions. How can we extend the trig ratios to angles greater than 90 degrees? So obviously not all the angles will be limited to just 90 degrees, and angles can be circle around and around. So how do we deal with that? That's going to be our topic for 7.2. Before we go into the lessons examples, I would like to give you some definitions. So the very first one is, instead of the vocabularies, I'm going to give you some definitions. So for any angles, as you can see, I'm drawing here. For any angles, there will be two sides. So please remember, when you draw an angle, you always put down two sides. The one side is called the initial side. The other side is called the terminal side. Initial side and terminal side. So some people call initial as the starting point. Some people call the terminal as the ending point. So initial and terminal. So make sure you put two sides for any angles. And another thing is, you may hear people say what's in standard form of an angle. If you put your initial side and matches with think about the coordinate x-axis. If you match it with the x-axis, you put it right on top of the x-axis for the initial side. That's where we call it as the standard form. So no matter where your terminal side ends, as long as you put your initial side to be the horizontal x-axis, then that's the standard form. Next one, we're going to talk about coterminal angles. So coterminal angles, you can think of, it's going to be, the appearance may look the same, but how you reach to the path may be different. So I'm giving you, as you can see here, there are three angles. So why am I putting down three angles for the same? Like I said, the appearance of the angle may look the same to you, but how you get to from initial to terminal may be different. So first one, if I write this as a 30-degree angle. So initial aligns with our horizontal axis, which is the standard form. So that's measuring from initial to terminal. That's 30 degree, initial to terminals. How about the second one? So for the second one, if I go instead of, do you remember I said it's going to be the appearance will be the same, but how you reach it is going to be different. So I'm going to go instead of counterclockwise. I'm measuring it clockwise. So do you see that? You have the same initial. That's where I start. I go clockwise and I end up as, so this is my terminal side. Do they use the same initial and terminal? Yes, definitely. But the angle measurement is going to be the same? So one thing you have to remember, if you're measuring it in the opposite direction, clockwise, it's going to be a negative angle. So initial and terminal. So what's the angle measurement here? It's going to be negative 330 degrees because it's measuring clockwise. It's measuring clockwise. Okay, last one. From the initial side, I go around and I don't stop at the first time I meet the terminal side. I keep on going. Then the second time as I pass through the initial side, I hit the terminal side, then I stop. So what is the angle measurement here? So obviously it's going to be greater than 30 degrees, and for one complete cycle, it's going to be 360 degrees plus the 30 degrees. So it's going to be 390 degrees. So as you can see for these simple examples, they're using the same terminal side, but they all have the same initial and terminal side, but the different path you take, they end up with different angle measurement. That's what we call coterminal angles. So hopefully you understand the coterminal angles use the same initial and terminal side. The appearance looks the same, but the path is different. Now let's go into example number 1. So if I give you a coordinate, so there's a point here, the coordinate number is, so x is -4, y is -4 square root of 3. And I want to make the measurement, angle measurement here, theta. So what is it? How do I figure out the angle measurement, theta? So we're going to talk about reference angle in the second example, but just to so you know that we are not going to deal directly with this angle theta because it's greater than 90 degrees. So we are actually dealing with this angle measurement here, and I'm going to call it as phi. So I'm going to take this triangle. So take a look at this triangle, small triangle, and then I'm going to redraw it again. Okay? It has an angle measurement of phi. And I know because of the coordinate I'm given, I know that this is going to be 4. It would have a length of 4 because the x coordinate is 4. The y coordinate is going to be 4 square root of 3. So I have the adjacent side of angle phi. I have the opposite side of angle phi. So what trig ratio should I use? Opposite and adjacent. Opposite and adjacent. So I'm going to use tangent. Tangent is opposite over adjacent. Opposite over adjacent. So what's 4 square root of 3 over 4? I can cancel out the 4, reduce that down to square root of 3. So how do I get the angle measurement of tangent of phi? So if you remember, we're going to use the inverse function. So hopefully you remember it from your geometry class. I'm going to use the inverse function of square root of 3, tangent square root of 3, to find out the angle measurement. So what is it? What is it? So let me switch to the calculator view. So hopefully you have that on your calculator. If you don't, and if you have an iPhone, then you can go to the app and find it with the TI calculator to use this one. So it looks exactly identical to what we have with the TI calculator. How do I find it? So first, as I mentioned, you want to make sure that your angle measurement is degree. Okay, so now I'm selecting degree. If you go into the mode and you see radians, make sure you switch to degrees. Make sure you switch to degrees. Okay, so how do I calculate the tangent square root of 3? So I'm going to use second tangent, which calls out the inverse functions, square root of 3, so square root of 3. So I want to find the angle measurement of square root of 3, which gives me the result as 60 degrees. So that's 60 degrees. So I know phi is going to be 60 degrees. But that's not the angle measurement we are looking for. What we are looking for is theta. We want to find theta. But you know that theta plus phi equals what? 180 degrees, right? What do we call that this in geometry class? Is it the supplementary? So these two angles add up to 180 degrees, so we call them supplementary angles, supplementary, right? 180 degrees. And we know that phi equals 60 degrees, so theta is going to be 180 minus 60, which is 120 degrees. In this way, we can calculate the angle measurement. And that's our example number 1. How about example number 2? So we're going to talk about reference angle here. And if you remember from your geometry class discussions, all the angles in first quadrant. So I'm drawing you in the fourth quadrant here. First quadrant, we call it quadrant 1. Second quadrant, we go counterclockwise again. So we go counterclockwise. First quadrant, second quadrant, third quadrant, and then fourth quadrant. Okay, we go counterclockwise. So make sure you revisit this if you forgot. And then we're going to refer this to as the bow tie angles. So theta in the first quadrant, in the first quadrant. All the other angle measurement, I'm going to try to reduce them using the reference angle concept and make it into the first quadrant angles, less than 90 degrees. Okay, so this would mean that they are this angle measurement here, and then this angle measurement here, and then this angle measurement here. With all the reference initial side setting on the horizontal side, you see that I am always referencing to the x-axis. I am not making any angle measurement with the y. So please remember, when it comes to reference angle, we are always referring to the x-axis. So first example, find the reference angle for 210. Find the reference angle for 210. And before we go into these examples, I would like to show you one thing that it's going to be on your, if you are taking the pre-calc class next year, this would be the one that you are going to use and memorize later on. So you might as well just take a look right now and try to remember it, okay? So with different color, you can see that there's blue, green, and then orange. So as you can see that they are almost like the bow tie angles. So they are crossing from each others with a bow tie, like it's not a official name, but you will hear people say a lot. They are facing each others across, and they have the same angle measurement. Back to our example. Find the reference angle for 210 degrees. So 210 degrees, how do I draw that? So let me make a sketch. Remember, when it comes to this type of question, I like to give myself a quick sketch. 210. So it's going to be the angle measurement here, the small angles, right? So it's going to be, so remember we're using the bow tie concept. So what is this angle measurement? So 210 obviously is going to be in the angle between 180. So this is 180 and this is 270. 210 is between 180 to 270. So what is this angle measurement? In the what is the reference angle for this 210? So I'm going to take 210 subtracting 180. So do you see that? I am subtracting 180 degrees, which gives me 30 degrees. So it's going to be 30 degrees reference angle for 210. Next one, find the reference angle for 130 degree. 130 degree. Where's 130 degree? Where's the terminal side for 130 degree? So if I put my initial side on the x-axis, 130 degree is going to be here. It's going to be in between 90 degree and 180 degrees, right? So 130 degree here. And which angle, reference angle, are we going to look at? It's this one, okay? Always refer to the x-axis, okay? Do you see that? The terminal side and then the x-axis. So what is that angle measurement? So obviously I'm going to take 180 degree, subtract 130 degree. Okay, always with respect to the x-axis. So what's 180 minus 130? So that's 50 degrees. So that means the reference angle for 130 is going to be 50 degrees. So using this concept, you can reduce the angles if it's greater than 90 degrees down to less than 90 degrees. So keep in mind, we are always referencing to the angle measurement on the x-axis. We are always referencing to the angle measurement on the x-axis, Okay? Example number 3. Again, before we go into example number 3, I'm going to show you this. Once again, the unit circle. We're going to reference to this over and over a lot later on. Unit circle, as you can read from my notes here, unit circle, why do we call it unit? Because it has a radius of 1. You would have a radius of 1. So think in your head, radius r equals 1. You would have a radius of 1. So how do we figure out the angle measure? How do we use this to help us find the trig ratios? Let me draw the unit circle. Remember the graph that I show you? I will post that graph to our Google Classroom, or you can Google search it yourself. There are many references of the unit circle online. Okay, so this is going to be 0 degrees. So going once again counterclockwise. This is 90 degree, 0, 90, 180, 270, and then back to 360s. So some people may be wondering, 360 and 0 degree, are they the same? They're exactly the same. They use the initials, they have the same initial side and then the terminal side. So they have the same initial side and the terminal side for 0 degree and 360 degrees. And as I mentioned earlier, the unit circle is all because it's using the name, the radius is 1. So if I draw a small triangle here, you can see that it would have the x and y values, The angle measurement here, theta. This would be x, and the opposite side is y. You would have a unit circle length of 1, r equals 1, right? So sine theta equals what? Hopefully by now you already remember the definition. Opposite over your hypotenuse. So opposite over your hypotenuse, and hypotenuse, the radius is always set to 1 for the unit circles. And then how about cosine theta? Cosine theta is adjacent over hypotenuse. And how about tangent theta? Tangent theta is opposite over adjacent, or some people refer it to as, so hopefully by now you will already notice that y over x is what? Slope. So this is actually the slope we're talking about. Tangent theta is just the slope. And before we go into the last example of the unit circles, we have to talk about radians. What is radians? I keep saying when you use your calculator, you have to make sure you are in radians or degrees. What's 1 radians? How do you measure the radius? Radians is actually you are strapping around. It's the radius that you wrap around the circles. You're going to wrap around the circles. So meaning that you are putting the radius onto the circles, mapping it onto the circles. So let me quickly draw a graph here. Circle. So if you have something like this, a radius of r, you try to take the same length and wrap it around a circle like this. Wrap it around a circle and it has the same length as r. The angle measurement here is going to be 1 radians. So theta is going to be 1 radians here. Okay, the openings that make up by putting the same length of your radius on the circle make up 1 radians. So do you remember that how many radians will you make if you have a full complete circles? So hopefully the most famous irrational numbers come to your mind. We can use the concept of 180 degree equals pi, or 360 degrees equals 2 pi's. So don't be confused with the English word pi. Even though when you're eating a pie, normally when you speak in English, pie, you're thinking about the whole pie. But when in math, pi is actually equal to 180 degree, which is half circle. So please remember that. With this, do you think that you can calculate the radians to degrees and then degrees converting back to radians? Let's take a look. If I ask you to convert 60 degrees into radians, how would you do that? You might have practiced this a lot in your science class of the unit conversions. How do you do that? So I'm going to use this one. 180 degree equals pi. 180 degree equals pi. You can definitely use 360 degree equals 2 pi, but then if you reduce, so do you see that? If you reduce the 2 on both sides, you are simplified down to 180 degrees equals pi. So I'm going to use the simple one, right? How do I convert this into the radians? So pi is in radians, and then I'm going to divide that. So 60 is a degree, so I'm going to divide it by 180 degrees. Obviously, 80 and 80 degree can be cancelled. So you have 60 divided by 180. Can you reduce them both by 60 to get pi over 3? So 60 divided by 180. I reduce top and bottom with 60. I have pi over 3 radians. And so let me show you the graph that I will post later. So do you see that? 60 degrees. 60 degrees. Do you see that on the graph here? It's going to show us pi over 3 radians. Pi over 3 radians. Okay, so just like I said, you're going to use this unit circle table and over in later on if you're taking a higher level math. So you might want to remember it. So if you can convert a degree into radians, do you think you can convert radians back into degrees? Let's take a look. What is pi over 4? Pi over 4 radians in degree. What's pi over 4 radians in degree? How do I convert that? So obviously I would have to multiply it by pi radians and then the 8 degrees on top. So think about your scientific class of the unit conversions. So obviously pi radians and pi radians, they get reduced from each other. So what is 180 degree divided by 4? What's 180 degree divided by 4? So the answer is going to be 45 degrees. So using this very simple concept, 100, let me emphasize it again. Using this 180 equals, so let me put a big 180 equals pi. 180 equals pi. You will be able to convert radians to degrees, degrees to radians, back and forth. That's the easiest formulas that you can remember to help you convert back and forth. So hopefully you are able to have some memories that you learned from the geometry class and extend to this unit circle, and then we're going to talk more about later if you're taking higher level math, as I mentioned, for math analysis or pre-calculus next years. If you have any questions, be sure to send me an email or let me know. I'll try to help you out with some discussions here.